Solids of revolution, the disk method. This is an application of integral. When you remember when we find the area under a curve, let's have this curve y equals the square root of x, and the area under it, it's the integration. The area will be the integration from a to b of the given curve, the given function, which is the square root of x. I prefer to write it as x exponent a half with respect to x. This is to find the area under the curve. When you spin or revolve the curve around x axis, what you're gonna have, imagine this figure, three-dimension figure. We call this semi-ellipsoid, which is when you revolve this curve around x-axis, what's gonna happen? You're gonna obtain this three-dimension figure here. It's not like truncated cone. It's a semi of the football. You know, football game. You know the football. It's semi of it, half it. To find the area under the curve, we got this integration, which is the integration from a to b of this function, the given function, square root of x with respect to x. And to find the volume of spinning, the result of revolving the curve around x-axis, is to set this equation. The volume equals pi, I prefer to start with pi, times the integration of r of x square with respect to x, and the bound will be bounds from a to b. Most of you confuse, and I don't see here confusion, because you remember pi r square. If you get the integration of the area, it will give us the volume. So we set pi as pi, and we have the bounds. It's from 0 to 4. We spin from 0 to 4 over x-axis. So the integration will be from 0 to 4. And the given function, which is the square root of x, and here square root of x, this will be spin around x-axis. So it will be x exponent a half, and we square it. So the function is square times pi. The function is square times pi with respect to x. And now if you multiply a half times 2, it will be x. So you integrate from 0 to 4 of x with respect to x. And the integration of x is x squared over 2. And we still have pi outside. And your bounds is from 0 to 4. And now we're going to start to apply this formula. The result of integration will be pi, f of pi 1 minus f of pi 2, or f of a1 minus f of a2, whatever you have in your question. So you substitute for 4, it will be pi 4 squared divided by 2, minus, you substitute for 0, it will be pi times 0 squared over 2. That will be 16 divided by 2, which is 8 pi. And this will be 0. 0 squared is 0 divided by 2 is 0 times pi is pi. So pi times 0 is 0. So 8 pi minus 0 equals 8 pi. So the volume of this figure, we call it semi-ellipsoid, is 8 pi unit cubed.